of academic knowledge, and this is to which that we bring knowledge that will be vital to you as you study. So I would like you to subscribe, hit the subscription button, like and share, drop your comment in the comment section. So that is it. So quickly, let us go to what we have today. We'll be treating amino acids. Amino acids. From the board, you can see that amino acids are building blocks of proteins. Amino acids are building blocks of proteins. Every protein you see contains long chain of amino acids, and just like the letters of the alphabet can make different words in like manner, different amino acids make up proteins. Yeah, they make up proteins. So amino acids are building blocks of proteins. And amino acids can be further divided into two classes: essential amino acids and non-essential amino acids. Essential amino acids, they are 9 in number. These are the ones we can get from what we eat, the food we eat. They are food cutting. You get them from the food you eat. Non-essential amino acids are the amino acids produced by the body. They are 11 in number. So now let's look at the essential amino acids. We have the 9 in number. We have the histidine, the isoleucine, leucine, lysine, methionine, the phenylalanine, the threonine, the tryptophan, and the valine. So for easy understanding, you can use an acronym for you to recall it. H I L L M E T T D. So this acronym, you can always use it to recall the 9 essential amino acids. Now for the non-essential amino acids, those produced by the body, we have the alanine, the arginine, the asparagine, the aspartic acid, the cysteine, the glutamic acid, the glutamine, the glycine, the proline, the serine, and tyrosine. They are 11 in number. So this is an acronym you can use to remember it. The last 4 is C double G, triple G, P S T. 1, 2, 3, 4, 5, 6. So it is 11 in number. So that is it. Now the next thing we are going to be looking into is the structure structure of amino acids. The structure of amino acids. Alright, so talking on the structure of amino acids. Now there are three things that are common to every amino acid. The first one is the basic amino group, which is the NH2, the acidic carboxyl group, which is the COOH, and an organic R group or side chain. So that is the basic structure of every amino acid. Now, what makes amino acid different from the other is this arrow group. This arrow group. In every amino acid you know, you get to see the presence of this amino group, this carboxylic group, but the difference is seen in this arrow group. So you can see the general formula. This is the amino group. The amino group. This is the amino group. This is the R group I'm telling you about. The R group on the side chain. And this is the carboxylic group. So take notes in your exams. They might ask you the component of an amino acid or what is the general formula of an amino acid. And I also see that this carbon atom is attached to the amino group to a central hydrogen atom, to a carboxylic group, then to the R group that is different in every amino acid. Like that of alanine, the R group of alanine is different from that of glutamic acid or valine. So we will now look at the classifications of amino acids. Amino acids are classified based on the nature of the R group. They are classified based on the nature of R group. The goal of this class is that after the class, we all can now single-handedly be able to draw the structural formula of these 20 basic amino acids. So in the classification, I'm going to classify them into groups, and these classifications would help us draw them and know them often, because most of the past questions you can see questions like draw the 20 amino acids, like write out the structural formula of 20 amino acids. So I'll be classifying them now, and that will help you to know how to draw them by heart. Alright, so the first classification of amino acids here are the non-polar aliphatic R group. Like I told you that what makes an amino acid different from another is the R group. Now, if you look at the R group of each of these, you see that they are different. The six of non-polar aliphatic R group, they have the carboxylate group, the amino group, and the R group. And what makes them different is this arrow group. Now, you can see that alanine is different from valine, from leucine, from leucine, and methionine, glycine. What makes them different is this one, arrow group. So, a simple way on how to learn how to draw. The first one is this alanine in this member. So you know that the carbon is bonded to 4 atoms. So when you draw a carbon atom, it will have 4 bonds. One leads to this amino group. Take note in your drawing. Know that this bond, this single bond is connected to nitrogen. This single bond here is connected to carbon, and this single bond here is connected to the hydrogen bond. So take note, because most lecturers do watch it and see that this carbon bond is connected to carbon, not to hydrogen. So in your drawing, you should be very careful. So in order to memorize how to draw these things offhand, so there are six of these amino acids that are classified under non-polar aliphatic group. So the first one is alanine. You see that all of them have the same structure. What is different is the arrow group. So alanine, what makes alanine different from others is the presence of CH3. The presence of what? CH3. And this is the structure of alanine. Now the first one, I also write is ALA. That is short form. The next one is valine. Now you see that, look at the hydrogen atom, the carboxylic group, the amino group. Now the arrow group of valine is different from that of alanine. You can see the bond bonded to a carbon first, then this carbon is bonded to CH3. CH3 is bonded to hydrogen, then to CH3. The next one is leucine. The next one is what? Leucine. The hydrogen group, the amino group, the carboxylic group. Now this carbon atom first of all bonded to CH2, then it trickles down to another carbon bond that is bonded to CH3, H, then CH3. Now this one, glycine is very simple. The amino group, you see OH, H, then glycine is just bonded to a hydrogen atom. The arrow group is a hydrogen atom. Then the isoleucine, the arrow group is, this carbon atom is bonded to an arrow group which extends to form CH3, hydrogen atom, extending again to form CH2, CH3. So take note of this arrow group. Now the last one is methionine. So the arrow group, the striking feature of this methionine is that it has sulfur. There is the presence of sulfur here. It has sulfur. So the arrow group is CH2, then sulfur, then CH3. So take note. So in your memorization, your main focus should be the arrow group that makes one amino acid different from the other. So just take note of it. So the next classification is the aromatic R group. The aromatic R group. That is the next classification. The aromatic R group. The aromatic R group. Let me pause the video. So the next group is the aromatic side group. The aromatic what? Side group. And they are aromatic side group because they have aromatic side chain. So the first here is phenylalanine. The second one is triosine and tryptophan. Tryptophan. So like you can see, the three constants are here. This. Now for this one, for phenylalanine is the R group is CH2, and this one is bonded to one like this. So this is sorry. So this is phenylalanine. Now for triosine, it's the same thing, CH2, which is bonded to M plus OH, hydroxyl. Now for this one, tryptophan, and see it is bonded to CH group, which is bonded to carbon, to CH, to NH, and this. So just know how to draw it. It's very simple to learn. After now, you pause the video and learn by yourself. So the next group is the polar charged amino acid. Polar charged amino acid. Polar charged amino acid. Alright, so the next group is the polar uncharged R group. Polar uncharged R group. And the first here is the serine. The serine. The serine. So serine has this structure. CH2 OH. CH2 OH. Now for cysteine has CH2 SH. CH2 SH, that is the arrow group. For asparagine. This is the formula. Bonded to hydrogen or bonded to carboxyl group. These are the bonded CH2. Bonded to oxygen. Bonded to NH2. So this one is for asparagine. Take note. This is for asparagine. Then for glutamine, it's almost the same thing. CH2 bonded to another CH2. Then bonded to H, C0. So I can have space. CH2 bonded to CH2. Then bonded to C. Now bonded to oxygen. Then NH2. And the last in this polar listing, polar and charge group is threonine, which the structural formula is central carbon bonded to COOH, bonded to the amino group, then to the hydrogen atom on top. This one is bonded to carbon. Carbon is bonded to OH, bonded to hydrogen and CH3. So these are the structural formula for polar uncharged iron group. The serine, the cysteine, is asparagine, and the formula here, the glutamine, and the so the next one we're taking is the acidic group. Acidic group. Let me pause the video. Okay, so the next one is the acidic R group. Acidic R group. The first one is aspartate and glutamate. Okay, aspartate is also known as aspartic acid. This one is also known as glutamic acid. Now, one thing is striking about this acidic R group, because they have a second carboxyl group. They have a second carboxyl group. They have a second one, carboxyl group. So, in order to draw the structural formula of aspartate, let's draw the constant connect to COOH hydrogen to and this one is bonded to CH2. Then it is also bonded to a second carboxyl group OH. So this is the drawing for aspartate to aspartic acid. Now for that of glutamate or glutamic acid, let's draw the basic structures. We have the carbon bonded to 4 COOH, bonded to CH2, another CH2, then to the second carboxyl group. Now the final classification is basic R group, basic what? R group, basic R group. So take note, the basic R group. Now the last group here is the basic R group. The basic R group. Now I've drawn the constants. And for lysine, why they are called basic R group? Because they have a second basic group. Now for lysine is one of them, arginine and histidine. So this is the structure of lysine: CH2 bonded to another CH2, bonded to another CH2, bonded to another CH2, and finally to NH2. This is the basic group. Now for arginine, the R group that makes it different from the other is CH2 bonded to another CH2, bonded to another CH2, bonded to NH, bonded to carbon, then to to another NH, then finally to NH2. Then the last one is histidine. The last one is what? Histidine. CH2 bonded to CH, bonded to NH, bonded to CH, bonded to nitrogen, bonded to CH. So please, while drawing and while learning how to memorize this offhand, make sure that the single bonds are connected to the carbon bond. Or some students, while making the mistake, they might draw something like CH2. See, they will now put CH here and draw it like this. It's a band. Sorry, it's wrong. Not is a band. It's wrong. It's wrong to draw stuff like this. So I want you to take your time, play the video over and over again. Take your time and learn them, because it is a must. It's a must. You'll be asked to draw these structures. Try to memorize them by using acronyms, like when we talked about essential and non-essential amino acids. Now for learning the structures, using these classifications, it will help you to draw the basic group, the acidic group, non-polar group, the polar group, and the aromatic group. So thank you so much. I'd like you to hit the subscription button, like, share, and drop your comment in the comment section.